Build AI apps with Python in NeoVim. Episode 12. Why RAG? Retrieval Augmented Generation. Claude knows a lot, but it does not know your data, your company handbook, your internal docs. Without your data, Claude guesses. It hallucinates. It makes up answers that sound real but are wrong. RAG fixes this. You retrieve relevant documents and inject them into the prompt. Today, a side-by-side comparison. Same question, with and without context. Watch the difference. A new file. Phase 3 begins. Retrieval Augmented Generation. Episode 12. The most important concept for real-world AI apps. Why RAG? The answer changes everything about how you build AI apps. Same imports. OS for environment variables. .env loads the API key from the env file. Anthropic client. No new libraries needed for basic RAG. Load key, create client. The foundation we built in phase 1. RAG does not require special tools, just smart prompt construction. Now the key ingredient. A fictional company handbook. A triple quoted string. Claude has never seen this document. Acme Corp. 2026 edition. Private data that does not exist on the internet. Remote work policy. 3 days per week minimum. Manager approval required. Specific rules Claude cannot guess. Think of it like an open book exam. Without the book, you guess. Fridays are mandatory in office. These are exact company rules. Leave policy section. Every company has data like this. "18 days annual leave." This is the number we will test Claude on. "14 days sick leave." Exact numbers Claude cannot guess correctly. "16 weeks parental leave." HR policies, product specs, customer records. Tech allowance section. More private company data. $2,500 per year. Large language models are trained once. Your data changes daily. No fine-tuning needed. No retraining. Just include the document in the prompt. Approved items list. Laptops, monitors, peripherals. Triple quotes close the string. The handbook is ready. Save. The document is defined. The question, how many days of annual leave? The answer is 18, but only with the handbook. First test, without RAG. No handbook, just the question. Print a header so we can compare the two results side by side. Same messages. Create we have used since episode 1. Claude Sonnet. Same model for both tests. Max tokens 1024. Plenty of room for an answer. The system prompt says, "Be honest if you do not know." The user message is just the question. No context, no handbook. Like asking someone about a book they have never read. Print the response. This is the hallucination test. Now the RAG version. Same question, but we inject the handbook. Print with RAG header. Side-by-side comparison. The RAG message is an F string. Document first, then question. This is the core RAG pattern. Use the following document to answer. The handbook text is injected directly into the user message. The question comes after the document. Claude sees both at once. Same API call, same model, same max tokens. The F string is the simplest RAG implementation. Document plus question. In real apps, you retrieve the document from a database first. The system prompt says, "Answer based only on the provided document." This tells Claude to stick to the facts. No guessing allowed. Close the API call. Same structure, different context. Print the response. This time the answer should be accurate. Save and run. Without RAG versus with RAG. Watch the difference in accuracy. Without RAG first. Claude does not know Acme Corp. It guesses or admits it. The answer is vague or wrong. Hallucination. Confident but incorrect. Now with RAG. Claude reads the handbook and finds the exact answer. 18 days annual leave. Accurate. The document was in the prompt. Same question. Same model. Context changes everything. That is RAG. Back to top. That is RAG. Recap. 3 key takeaways. First, Claude hallucinates on data it has never seen. It guesses or admits it does not know. Second, RAG injects relevant documents into the prompt. Same API, accurate answers. Third, the system prompt says answer from the document only. This prevents mixing in guesses. Thanks for watching. Next episode, text splitting. Breaking documents into chunks.